So, so in yesterday's class, we have started our concept, which is called RAG. So what exactly RAG stands for? RAG stands for retrieval, augment, generation. So in retrieval part, what we are doing is we have some database that is vector database, or we call it as vector store. So I'm a user. I'm asking a query. So that whatever the query is, that query is generally redirected to vector database. And then from vector database, what we will do is we will fetch the most relevant information with respect to this query. So once after getting the relevant information, once after fetching the relevant information, what we do is we augment that and then we'll pass that information to LLM. So, and then what LLM does is that LLM, based on the context that you are providing for the question, it generates the response. So first we are doing fetching, and then we are augmenting the context with the question, and then after passing that context from the question to LLM, LLM is generating the response. So this is what a basic RAG is, and then let's say we have companies' documents. To send these documents to vector database, what we are doing, we are following a procedure. What is that procedure? So generally, we are taking these documents and then we are doing something called chunking. What is the process of what is the main purpose of chunking is whatever the last document is, if you convert that entire a large document and then if you store that large document, I mean, into the vector database, it is very hard whenever you are doing the retrieval process. So for the further simplification, what we are doing is we are whatever the document that we are having, we are doing the chunking. So chunking is breaking down the bigger document with larger text into the smaller documents. So once after doing the chunking, we are doing something called embedding. So embedding is converting the text into vectors. And once after doing this converting the text into vectors, we are storing that information into vector database. So this is what we have seen yesterday in yesterday's class. In today's class, we will see what are different type of chunking strategies are there. So in yesterday's class, we have seen something called character text splitting. What does splitting does is that it splits. I mean, the splitting strategy there is we split based on number of characters. But the drawback of character split text splitter is it doesn't preserve the context. Let's say if my context size is 100, irrespective of the let's say if my word whatever the I mean if you are using character text splitter, the drawback is that we don't preserve the semantics. What do I mean by that is if my 100th word is half of the word, then I might be storing half in one chunk and the other half in other chunk. So yeah, that is the drawback of character text splitter, where we don't. I mean, I'll talk about that in detail whenever I'm talking about text splitters now. Yeah, but in yesterday's class we have seen that. So we will talk about the text splitters, and then we'll also talk about embedding techniques. So I think in yesterday's class we have used OpenAI embedding technique. In addition to that, I'll also introduce you to something called Hugging Face Transformer, wherein again I'll let you know what exactly Hugging Face is, and then I'll take you through Hugging Face Transformers embeddings as well. And then while loading this stuff, we use something called a text loader. If you can remember, we have stored our data in my local system. Here instead of DB, what I store, I mean in my local desktop, I stored all my text files, right? I store all my text files. And then if I want to load this text file, we use something called text loader. Yes or no? Or what if I want to load PDF? What if I want to load any Wikipedia data or website data? How can I do that? We'll see all these loaders. So in today's class, we will be discussing about three components. One is loaders, second one is text splitters, and third one is embeddings. If time permits, I'll also talk about retriever. So in retriever, I'm saying that we are retrieving the relevant chunks, right? How are we retrieving that? What are we in yesterday's class we have seen something called similarity score. What are other parameters? Which are alternative to similarity score? We'll see that as well if time permits. Okay. So this is an agendas for today's class. Let's see how it goes. So yeah. So I mean, in document loaders, let's say if I have only the text files in my cloud environment or in my local environment, I use something called text loader. What text loader does is that it loads the text file into the working directory. So here, I'm using text loader to load something called speech.txt. So in my rag folder, I had something called material. In this material, I have some one file name which is called speech.txt. So in that speech.txt, what I'm doing is I'm just loading that using text loader. So if I want to load any text files using LangChain, what is the library that I have to use? I have to use this module, which is document loaders module, which is present in LangChain underscore community. And then I'm just loading my file, whatever the text file is, I'm loading that by passing that as a parameter. This is how we load a text file. And then, once after loading that, here we are just creating just like, and we are just creating an object to that file. Now I just want to actually load the content. So here, if I load the content, see here, text document underscore documents is equal to loader dot load. So after, if I print that text underscore document, this is the information that I'm getting. Metadata says that the source is the file name material slash speech, and then what is page content? There is a hell lot of page content. Whatever the content here is, we got that page content here. Okay, this is the loading of the text file. Let's say if I want to load PDFs in LangChain, we have something called PyPDF. PyPDF is the library where which we are using to load the PDFs actually. So I have one PDF. Here the PDF is attention.pdf, where that is a research paper which says attention is all you need. The transformer research paper actually, which is released in 2017. Yeah, I'm just loading that paper actually here. So what I am doing is here, if you want to load text file, we had something called text loader, right? Similarly, if I want to load the PDFs, we have something called PyPDF loader, and then uh, I'm just using PyPDF loader of the material, and then I'm just having something called loader.load so that my PDF is loaded here. Okay. And then the difference between the text loader and then PDF loader is uh, the text loader. It loads. If you use loader.load, it loads the. It not. it doesn't load the entire text file. It loads in chunks actually. It loads in smaller. I mean, let's say uh, if my text file is around 100 pages, it loads with some limitations actually. It loads in the list format. It loads list of documents which is present in that entire document. So let's say if my text file is of 100 pages, if I run this code, loader.load, what happens internally is that the whatever the text file that I'm having, it loads into smaller chunks. It loads into list of docs actually. Whatever the main doc is, we are loading that into list of docs. And it is sub docs actually. Similarly, if you loader.load, it does the same thing actually. It chunks. Uh, it is inter this chunking is not the proper chunking, but instead of loading the entire all the pages, it loads a document by document actually. And then if you see the type of the doc, see here doc is the it is the page information. You can assume that, let's say if my attention PDF is having 12 pages, so one page is, let's assume that one page can be one doc. So type of doc would be document. So this is how we load the PDF file. What if my PDF file has some images, or what if my PDF file has something called tables? What do we do in that cases? So what we do is that we use something called OCR techniques, uh, where we recognize what are contents that are available in the PDF actually. For that, there are few Amazon services, or else you can use any object detection techniques which are present in computer vision. But most of us most of the companies uses some OCR techniques, which is Amazon is having a service called Tech Extract, where it reads the PDF, it recognizes the objects, and then it returns the. If you want, you can get all the you can extract the contents from the PDF actually. So yeah, so you can for smaller PDFs without any images or without tables, you can use this PyPDF loader. But if you have the complex PDFs with the complex sections, subsections, followed by uh, followed by some images, you can use. Uh, I said you can use the Amazon Stack Extract to extract the content that is present in the PDF. Okay, this is how we load PDFs. Uh, and then if I want to if I want to get websites data that is present in the website to load websites content data, we have something called BS4. BS4 stands for beautiful soap actually. So this is just a web scraping. So here, instead of text loader, PyPDF loader, we use something called web-based loader, where I'm passing the website link. And then this is it is just a the syntax that we need to follow, where we need to have a dictionary, and then we need to have a parameter which is parse underscore only, and then we need to create an object for soap stainer. So this is a bit of Python code. What we are generally doing is that we are scraping the data that is available in this website. So here we are using web scraper. Internally, it uses web scraper, but yeah, we can also scrap the data from websites. And
Shekhar,
then okay,
1 second, Shekhar. So
okay.
you created PDF loader and text loaders, right?
Uh-huh.
Uh, some scenarios you have like very large data sets in the files.
Mm-hmm.
In that case, are we still using the same
Yeah,
this?
we will be using the same loaders, but the thing is that whatever the file size is, it doesn't matter. Whatever the complexity of file doesn't matter, but we need to use. As I said, we can use either of these, or we can use mm, the Amazon Stack Exchange. if I want to extract the complexity, if there is complex data in the PDF, we can use that service as well.
I see. Okay, okay, okay.
But
Got
I
it.
mean, if my file is too long, what I will do is I'll do chunking, and then I'll store this whatever the big file is. I'll store the chunks into my vector database. So file size doesn't matter. But only thing is that we need to know what to use when.
Okay, okay.
Second, can you
Go
show
ahead.
that web scrapper again?
Okay.
Yeah, I just want to see. So can you explain briefly
Okay,
again
sure.
till I
Okay,
understand?
okay, okay. So, what I am doing here is that I am using, I mean, in the document loaders, we have something in addition to a text splitter, and then in addition to PyPDF loader, we have something called web-based uh, loader, where it loads the entire whatever the content that is present in the website, it loads that. So, if you want to check what is in this. There is some content. There is some. I mean, there is huge content on LLM-powered autonomous agents. So what it does is that it will extract the content that is present in this website with the help of a beautiful soap. Actually, I mean, there is a beautiful library that is present in Python, which is called Beautiful Loop.
Sorry for the interruption.
Go
Yeah, you
ahead.
said that there is a URL. You said that the entire content in the entire website or in that particular page content.
In this page content, whatever the content that is present in this page content, entire content will be extracted.
Oh, got it. Thank you.
Yeah. So what the beautiful soap does is that it extracts the content that is present in this web page, and then we are storing that in loader. And then if you load that, if you do load dot load, you can see the entire content is extracted in the entire content is extracted from that website actually. So yeah, I mean, we generally don't use this. I mean, in most of the companies, data either will be in PDFs or once after extracting the content from PDFs, we can have sometimes we sometimes have the text files also. So we mostly use either one of two, but I just want to show that this is also available in LangChain.
So this
And then
gives
there is,
only the text, all the text, right? Whatever. Oh.
yeah, it only scraps the text, not the images or something like that. Yeah. And we had something called Wikipedia loader. What this Wikipedia loader does is that whatever the question that you are asking, I mean, it's just an API call. You can assume that it is an API call to Wikipedia loader with this query, and then uh, Wikipedia will be having so many articles and then some information on GenAI, right? So we will be getting some information with respect to this GenAI by using this Wikipedia loader. We had something called Wikipedia loader, where if you pass the query like GenAI or president or how president of United States is elected, or if you pass any question, so this question will be passed to Wikipedia loader page, and then we'll get the content from that Wikipedia actually. And then, yeah, we are storing whatever the content that we are getting from the Wikipedia loader, we are storing that in docs, and then we are printing that actually. So, yeah, these are the four. I mean, I just have listed only the four, but if you want to go deep into this, uh, I mean, LangChain, it does supports more as well. So you can go and check if you want more. But most of the things that we will be using is either one or two based on the content that is available. In addition to this, as I said, we will be using either of the cloud providers. It can be AWS or it can be Azure or it can be Google, where they are having their own OCR techniques. We will be using that OCR techniques to extract the content. And if I want to talk about the text splitters, uh, text splitters. There are, as I said, I will be talking about so many text splitters in this class. One is character text splitter, where in yesterday's class we have also used this character split text splitter. What we are doing with text character splitter is we split based on the characters. Just give me a moment. I want to open that website. Just 1 minute, guys. So, yeah, this is a chunking visualization website where you can check how exactly chunking happens. This is a very helpful website where you can go and check how chunking happens. So, in character splitter, see here, what I am doing is I am passing 25 as my output. So if I pass 25, what it does is that it splits based on the number of characters. So if I pass 25, the 25, only 25 characters based on each 25 characters, it will be split actually. The content will be split. But in yesterday's class, someone has raised a question. Whenever I'm running program, I have shown you some basic program, right? In that, what text splitter has done is that it splits unevenly. I don't remember the exact name of the guy who has raised that, but it is a valid question. So just give me a moment. Yeah, I rerun this. That is the reason why it is saying that the vector store already exists. But what happened there is that even though our chunk size is 1,000, uh, the splitting doesn't happen at 1,000. It happened at somewhere actually. So I'll answer that question today. Whenever we are taking, I'll take you through this example so that you'll get a more understanding of why it does. So see here, I'm just loading my speech.txt file. I'm loading that, and then here I want to split based on a text character splitter. For text character splitter, we had three parameters. One is separator, second one is chunk size, third one is overlap. So the chunk size would be number of characters that we need to consider to do the chunking, and then chunk overlap would be 20. So chunk overlap is how much is the overlap that we need to consider. Let's say if I say 3, so here the chunk, if it is 3, only last 3 characters are same in this chunk and the next chunk. Okay. And then what is the separator here? The separator is, uh, I mean, basically the separator, here I'm passing double n, which what do I meant by that is a new para. New para is this separator that I want. So what is slash n? Slash n would be new line character where I want to divide chunks based on the paragraphs here, but whenever I'm splitting, uh, whenever I'm splitting my entire chunk, entire document, I need to consider only the 100 characters. So what happens here is that even though I am asking my character text splitters to split with 100 characters, what it is doing is it is chunking with 470. See here, it created a chunk size with 470, and it is saying that which is more than 100. Here it is creating chunk with 347 characters, but specifically we are mentioning 100 as an output. Why is it doing is that internally, the chunk, how this character chunk logic has written is that, uh, it doesn't splits based on the chunk size if it doesn't encounters the new para. Let's say if I have a text, if I have a text with 100 characters, and let's say if my chunk size is 100, and then if I have a next para in the, I mean, next para in this in the entire document, then I will not face any difficulty whenever I'm using a character splitter. If my chunk size is less, and if I have more text which within that paragraph, what chain splitter character splitter will do is that it will ignore our chain size, and then it will split until it encounters the new paragraph. Okay, so how this character text splitter is implemented internally is, even though uh, even though we have specifically mentioned our chunk size to be 100, where I want only to have 100 characters in my chunk, because the chunk size character is not as it is not encountering the delimiter. Here our delimiter is /n/n, which is new paragraph. As it is not encountering that as it is not encountering /n/n after 100 characters, what it is doing is that it is splitting until it encounters /n/n actually. That is the reason why here we are not able to split based on our exact specific count, and it is splitting based on whenever until it encounters the new paragraph actually. Hope that answers whoever asked the question and then whoever are listening uh, to this
Shekhar,
thing.
new
Hmm?
paragraph or new line?
New line would be /n. If I say /n, it would be
Correct.
new line. Here /n/n is new paragraph.
Oh, I see. Okay.
Yeah,
New
yeah.
paragraph, in the sense it will read entire, like, if there is a paragraph is like, two lines,
It
it
will
will read.
read the two lines. Even though our chain size is 100, it ignores 100 and then it will read the entire two lines.
So, okay. I see. So slash
Mhm.
and slash, that means it's a paragraph. Only.
Delimiter.
Okay.
Yeah, paragraph delimiter. Yeah.
So then what is the purpose of giving
Purpose.
100?
Okay. I mean, we generally in industries, people generally don't use this character splitter because splitting based on characters is a foolish thing. We want entire word, right? We want to store word semantics. Semantics is nothing but meanings. We need to, let's say if I have this entire paragraph, this paragraph might give some information, right? This might give some information on HR policy, or this might give some information on any of the content, right? So whenever we are uh, splitting something, you need to maintain that semantics. So this character splitting doesn't make any sense, but in what cases we need to use this character splitting is, let's say if our text is uh, well curated and then it doesn't have unevenness, then you might use this character splitting. But as I said, character splitting is not that efficient one, and then it even not even follows the rule to break with some size. Let's say if it is 100, it is not following that, and then it is going beyond that. Okay, and as I said, character text splitter is not widely used stuff. Most of the people will be using recursive character splitter or the advanced versions, such as sentence-based splitting. We have something called custom splitting, where you can write your own logic to split the documents actually to do this checking. Okay. Yeah, and then this is the first thing. The first thing would be we will be parsing the entire document. But whenever we are doing the character splitting is done with the number of characters based on the characters. But if it doesn't encounters the delimiter, it will parse until the end of the paragraph actually. And what does this recursive character split does is that
So the delimiter will override the character limit?
yes, delimiter will override the chunk size. That is what you are saying.
Yeah, the 100, whatever it is. So that is chunk size. Okay, yeah.
Yeah, chunk size. Yeah, if if in the text, if let's say till here is the 100th, all this is the 100 word. If here, if it doesn't encounters that, the chunk size will be updated to the length of the until I mean when until it encounters the slash n, it will go on, and then whenever it encounters the slash n, then it will split until that point actually, and it consider this
Though
as
the
a chunk.
size is more than 100 or less than 100, doesn't matter.
Yeah, it doesn't matter. Yeah, that is what we are seeing here. So even though
So
my chunk size is
basically,
100,
what you're saying is the parameter 1 and parameter 2 both should satisfy, only then it will split.
yes, it splits exactly with our chunk size. If not, it simply ignores the second parameter, and then it will parse until the new line. It will parse until the delimiter.
Right.
Yeah, that's about the text splitter. We had something called recursive text splitter.
Overlap 20 is what? Overlap 20? It
Overlap
will.
20 is, let's say, here, let's assume that my chunk size is 100. Uh, let Okay, here let's assume that my chunk size is 312 and my overlap is 10. Okay, so what happened is that between this chunk and then the next chunk, we need if you put overlap, these are the common words actually. So the output of the first chunk will be, I mean, the end words of the first chunk and then the next chunk will be same actually. That is what overlap. It is just to maintain the evenness, I mean, to get the correlation or to get some information from the last paragraph.
Do you have example here? There? No, we don't have, right? Okay.
Yeah, see, here is that T, if you see, this blue color is Shenk 1, and then this
Okay.
yellow color is Shenk 2, and then the
Okay.
green color highlighted thing is the overlap text between the first Shenk and then the second Shenk.
Okay. But this is okay. This is rarely. So that is the part of first and second.
Yeah, that is a part of
Okay.
first Shenk and the second Shenk. That is the overlap thing here, the chunk overlap.
Continuation kind of. Okay.
Okay.
Continuation.
Yeah, continuation kind of thing, yeah. And yeah, so what exactly the text splitting does is that text splitting is a bit intelligent one. Uh, so let's say if I load my attention thing, attention is, as I said, is a PDF. After loading this, what happens is that if I use recursive character text splitter with let's say chunk size to be 500 and overlap to be 50, what it does is that instead of checking for delimiter, here it will take so many delimiters actually. So the recursive character text splitter uses /n as delimiter, or /n as delimiter, or space or dot. It will consider all the delimiters and then it will split accordingly actually. Instead of only using /n /n as delimiter, which is in the case of a character splitter. What in recursive character splitter does is that if my chunk size, if I'm asking uh, to split base with 500 character words, okay, 500 maybe my chunk size with me with 500 words or 500 characters, what it does is that it will check for the dot. In the sentence it will check for the dot and it will go until the dot actually. So why are we going till the dot, or why are we going to the end is that we don't want to miss. There shouldn't be any. If, let's say if there is a context, the context should not split between the two. Uh, between the two chunks, and then some part of context should not be in first sentence, and then second some part should not be in second chunk actually. Let's assume that there is an HR policy. The HR policy states that if you are applying for maternity leave or paternity leave, these many are the leaves that you need to take as a full-time employee. Let's say if this is a paragraph, if you are splitting with 500 characters or something like that, then let's assume that if you split based on 100 characters, what happens is if you split based on 100 characters, there might be a high chance that some half of the information might go in one chunk, and then some half will go in the second chunk, right? And then partition might happen in the middle of the statement, or if you don't consider the semantics, there might be breakage, right? So in order to get some meaningfulness to the chunk, what this recursive text splitter will do is that it internally checks for, before it splits anything, it checks for the end of delimiter. It will not go until the new paragraph. It will not split something like that. So what this text splitter will do is that instead of waiting for the new paragraph, if it finds any full stop, then it recognizes that this is the end of the statement. That's good. I mean, I can split here. That is what recursive character splitter do. So this is bit smart compared to character test splitter, but we do have advanced versions of the text splitters than character splitter and recursive character splitter. We have something called context-based text splitting. We have something called paragraph-based splitting. We have something called sentence-based splitting. We have something called token-based splitting. Yeah, there are so many splitting strategies, but this is one of the type actually. So I'll walk you through that as well, but I'll take all those examples in the example that we are walking through. I'll include all those splitters here. Okay. So in
Shekhar, that
yesterday's
recursive
yeah.
splitter considers even space as a
Not exactly the space, but let's say if it finds 500 as the middle of the word, I mean, we might be running into, let's say, if I'm splitting this entire text, if my, let's say, chain size is 312, here it is good, but here it is I mean, here the chunk has breaked at chan, right? CHAN. So it will not, I mean, the recursive text splitter will not break here. It will consider until the new space. Okay, until the space, it will, I mean, the change will be in one chunk, and then the rules will be in other chunk actually. That is
okay.
what the splitter is. I mean, the space delimiter that I have mentioned there. Splitting is, I mean, bit hard, I mean, bit complex thing, because here, just give me a moment, guys. I'll plug my charger. So the problem with these splitters is, if you don't use proper splitters, what happens is that, as I said, you might see here fundamental is a word, but if you have any text splitter or recursive text splitter, if fun is in one chunk and then fundamental is in other chunk, then it comes, I mean, uh, let's say if you map this fun into a vector space, then fun has different meaning than dental, right? So, I mean, you should not break the words. So what this recursive splitter will do is that if it encounters 500 character at some point, it will not stop here. It will check for either the space, or it will check until the dot. I mean, that is what the bit smartness that recursive splitter has compared to the character splitter. Okay, let's check that with few examples so that you'll get more idea on this. So this is the example that we have considered yesterday. Just give me a moment, guys. Yeah, I think we haven't discussed metadata, right? Yet. Yeah. I think we haven't discussed metadata. I'll start from here. Yeah.
Yeah, no, we didn't.
So metadata is a very important thing whenever we are preparing vector stores actually. So what generally happens is that let's say, let me share my screen. So let's say I am creating a vector database and then I'm storing all my data, all the data that I'm having into vector database. This is my vector database. Okay. And what I am doing is I am having my PDFs here. I let's assume that this is my PDFs. Let's assume that you have used some techniques such as chunking strategies, and then you have embedded something. Okay, and then you stored everything in vector database. You did all this pre-processing stuff, and then you stored data into vector database. And then what you did is that user has a query, and then you fetched the relevant thing. You fetch, I mean, whatever the relevant context is, you fetched the relevant context, and then you did before you pass this question to LLM. What you do? You do augmentation, right? And then you pass this information to LLM. Sometimes what LLM does is that even though you are passing context, let's say if LLM has some predefined knowledge on any of the employees' maternity or paternity leave, there might be some sort of information that is trained on, right? LLM might trained on that data, right? So LLM might try to hallucinate. It's not hallucinating, but it might give some additional information if you still pass the context and then if you still pass the query. So if you pass this query and then the content, the context that you have received from LLM, there might be a chance that LLM might, I mean, I am not saying that 100% you'll get the hallucination, but let's say if it is trained on something, if it is trained on the same information, that the context that you are providing, there might be a chance that LLM might give us a bit hallucinated answer. So in order to skip this, what we can do is that we can add metadata to each chunk, and then whatever the chunk that it is retrieving, we want LLM. Let's say if LLM is giving answer from uh, LLM is, if you are retrieving some answer, if it is giving answers based on some chains, we want LLM in the final answer also, we want LLM to give that where it is taking from. What is the source the answer is coming from? If we have the source, then LLM might not hallucinate more actually. So in addition to context, we'll also pass the metadata for each chunk actually in order to reduce these hallucinations. And then if you have the document, that is an additional thing, right? Let's say I created a website where it is LLM powered actually. If I ask any question to uh, this chatbot based on this rag, this might give us the answer, right? And then in this side, if you can if you can reproduce that the documents, then it is very good, right? User might definitely go and check this document, right? So if you provide the reference documents from where from where this documentation, from where this LLM is answering from, that is a good thing, right? So I got the same question 1 year back when I am giving an interview for one company. They asked me at that point of time, they are planning to introduce this meta concept, I mean metadata concept. So they asked me, how do you retrieve? As LLM might tend to hallucinate, right? So they ask me question like, how do you get the metadata? Because LLMs might try to do this, right? So how do you add metadata to the strings, and then how do you ensure that LLM might take only data from that chunks, and then they want to show the these documents also. Yeah, this is the question that I got. Now I'll show that how we can include the metadata to our chains. Okay, so here what I am doing is uh, I am just creating a vector database that is chroma vector database, which is chroma underscore db with metadata. This is my name of the vector database or the name of the folder that I am creating. Inside that, what I am just doing is that I am just checking whether that vector data is available or not. If it is available, I'll not create vector database one more time, because if 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 the everything is processed and everything is stored into vector database, I don't need to do that. I can do querying, right? So yeah, that is the reason why if I don't have, then only I need to do this process. Okay.
Yeah. Shekhar, this vector
Mhm.
DB like a file system?
File. What do you mean by file system? I mean,
Okay. You are passing the file path, right? Inside file path,
mm-hmm,
and then there might be like, one file created
uh-huh,
inside
mm-hmm.
file. It's keep writing into the all zeros ones into that file, right?
Oh, you're saying that is the vector database is a kind of a file or not? Is that your question?
Uh,
Yeah,
um,
so he's asking like if we talk about database, right? So we have data being stored as a table
Mm-hmm,
or like a
mm-hmm,
blob. So when you
mm-hmm.
say a database, what is like a storage format it uses? Is it
Yeah,
just
okay, got it. Got
that
I
file?
see about the storage format with respect to this. We will talk about that whenever we are talking about vector databases. I have 2 to 3 classes on how the vector database is, how it is storing the data, how we generally fetch, how we push. We can talk about that whenever we are talking about that information.
sure, please go ahead. Yeah, yeah. Got
Yeah, yeah. So. Yeah, but I mean, it is just like, I mean, if I want to talk about the database, it is not like file system. It is just like a NoSQL database actually. Uh, but I mean, we do have indexing for the vectors. We just store just like the index followed by the content. Yeah, but the retrieval part is different compared to any SQL or NoSQL databases.
Okay,
Yeah.
got it. Sure, sure.
Mhm. So what I am doing here is that I'm just checking whether the book directory, it is just a if statement, but I have the book directory, right? So I don't want to bother about this. So here what I am doing is that I am looping over my directory. So here, as I'm having as it is in local, I'm looping here. If it is in cloud, you as I said, you can use Boto 3, and then you can connect to S3, and then you can loop to all the documents that are present in the S3. Yeah, this is local code, and then you can directly change this code uh, to the cloud or cloud provider, if you're using Amazon, or you can use Azure Blob Storage, or you can use any of the service, and then you can fetch the relevant files. So here I'm just checking I'm just only taking the text files for now. I think most of the files that are available in this book statement books are text files. So yeah, I'm taking that entire thing into files, and then what I am doing is I for each file that is present in this books folder, what I am doing is I just want the file path. The file path is here. It contains the name of the folder, and then bookdir is the folder actually. Bookdir is the folder until the rag, and then book file is the name of the file that is present in this book. So I'm just attaching the absolute path, entire relevant path with the absolute path. I mean, so I'm taking till what is the path till books, and then I want to copy this name as well. So I'm just merging that, and then I'm loading the file. I'm loading that whatever the file is, and then I load. Uh, I just want to load the entire the text file with the loader.load. So once after loader.load, once I do this loader.load, the thing that I'm getting here is that I will be getting a list of docs for that document. So for each thing, what I am doing is I am adding something called source. This is the metadata. I mean, I'm just only adding the source, but you can add any number of things like what, uh, let's say if you are working for HR policy or HR department, you can have in the source, in the metadata, you can have what is the source, who is the author that they have created, who is the one that is giving this file for you, what is it talking about, and then what is the department this file is associated to. You can have this entire metadata in this metadata column actually. And then now what
So
I'm
this,
doing
I
is
mean, is it a kind of label or what? Source, you're saying book file, or what does that source
here,
indicate?
yeah, source is just a path. Okay, so just let me show you the output. So yeah, if you can see, source is just a file name. I mean, what I want to show finally is that where this chunk is coming from. I want to know. See, whenever I ask the question like, "How did Julie die?" This is my question. So, I mean, my vector database is having so many chunks, right? There might be so many chunks that are present in my vector database. What I want to know is that whenever I am retrieving some chunk from the vector database, the thing that I want is that I want to know the source from where this chunk is coming from. So for that, what I am doing is I am creating source for each chunk actually. That is what I am doing here. For each doc that is present in that book, uh, I'm creating a metadata where it is just a file name. What I'm saying is that in addition to this, you can add any number of fields like title, or else you can add something like uh, page content, or you can add something like author, from where we are getting from, who created this file, what is the version of the document. You can add all the meta information of the book. That is what I'm saying. And then finally, what I am doing is I'm adding all the documents to my documents list. Here, what I just want to do is that once after adding this metadata for all the files that are available, I'm doing the character based chunking. Okay, so I'll split based on 100, even though it is here, even though here I'm just splitting at 1000, it doesn't matter, right? So it checks for that delimiter thing, and then it splits based on the delimiter thing. If delimiter thing is satisfied, it will split until that. If not, it will go until the end. And then, yeah, I did chunking. Once after doing the chunking, I am doing embedding. Here I'm using OpenAI embedding model. And then I'm converting the text into my vectors, and then I'm storing that into my vector database. Actually, here I'm using chroma vector database, and then I'm storing that. So once after storing that, here what I am doing is whatever the question is. Here the question is how did Julie die? This is my question. So for this question, I want to retrieve the information, right? So this is a question. What I need to do first, I need to convert this question into vector, because all the vectors, all the data is stored in vector database or vectors, right? So whatever you are passing also that need to convert it into vector. So I'm using OpenAI embeddings, and then I'm converting this into vector, and then I am fetching the results with. So I want to fetch top 3 results with some threshold. I want to fetch the similarity based on some similarity score. I want to fetch the most relevant chunks with this. I mean, with these conditions actually. So I want to fetch the relevant content from the vector database. Whenever I'm fetching, my relevancy should be, I want my chunks to be very similar. I want my similarity score. I'll talk about similarity score now, but I want to fetch uh, with one parameter which is called similarity score, and then I want to fetch top 3, which has score threshold of 10%. And then I'm calling my retriever engine with my query, and then I'm getting the relevant documents. The difference between the first thing that we have discussed and this is that here additional thing is that we are getting the source. The important thing is that whenever I'm fetching the relevant document, here we are displaying the metadata, and because we are storing the source of uh, each doc that is available. For each doc what we are creating is in the session we are creating the source, right? So the main thing is that we need source. If we have source, we can directly display that source to user, so that user will get to know whether this generation from LLM is correct or not, whether LLM is hallucinating or not. Okay, so here what we are just doing is that in my above code, what we are just doing is we are just adding the metadata. Okay,
But it is not really reducing hallucination, right? It is just
but
confirming.
yeah, it is not reducing, but we are, if you pass the source, and if strictly what I am doing is, see, in the end, I have one thing. Let me show you that. So here I'm asking LLM to provide information based on the document only. And then here I'm strictly asking the LLM, if you don't find the answer in the document, I'm asking LLM not to provide any random answer or something like that. So, I mean, in one sense, we might not fully reduce the hallucination, but if you have the source, there are two benefits. One, we can display that source information, which can be, I mean, we can display that file to the user. And the second thing would be, we will strictly say, LLM, this is the information that I'm getting from this chunk, and I want you to take this shrink. If you don't find answer in this shrink, I want LLM to not to give answer. So yeah, source helps in that case actually. It not completely reduces, but yeah, it partially. We can say some bit actually.
Got it. Yeah.
Yeah, but and having
Basically,
meta
you are
information.
just oh, sorry.
Okay, go ahead. Go ahead.
Yeah. So can I go ahead?
Yeah, go ahead. Go ahead, Kailash.
Yeah. So basically, the source or metadata, what you're doing is you're just naming the content in the file. Basically, maybe chapter wise you are dividing. It's a book, like
Yeah.
it has 100 pages. You are just
Mhm.
naming, okay, this page name is this, the other page is this, something like that. Or 10
And then
pages you're naming as a
yeah,
chapter.
Yeah, metadata is that, right? I mean, generally it says what exactly it says information about that document, what exactly the document is, who is the author of that document, or
Yeah.
any additional information about that document, or any information about that chunk will be present in that metadata. And then, as I said, we can, if we have metadata, we can retrieve that document, one thing. And the second thing would be, uh,
6 मतलब 6 बजे स्टार्ट होते हैं ना लोग तो 7 बजे तक
can you
आते
be
हैं
on mute,
Sujit,
guys?
Sujit, Roja, or Sujit is I think. Can you please go meet?
Yeah. So one thing would be, yeah, one, we are getting information, district information about the document. Uh, we are storing the information about that chunk in that meta information. And then we need this meta information in one thing actually. Let's say we are having vector database. I don't want to go in that deep, but let's say if you are having a vector database, and then let's say if we want to find what is the document that people are not using. I mean, after some days, let's say after creating my chatbot, I want to delete some chunks which are not at all retrieved in that year. So let's say in these cases, we might need metadata, where in metadata we can have something like counter variable. And then let's say if user retrieves this chunk, we will update that count actually. And then let's say if count is 0 after an year, we can remove that kind of chunks. So yeah, I mean, there is some importance to this metadata, but I don't want to go in deep now. Whenever we are talking about RAG thing, I mean, we can go ahead and discuss all those stuff. But this is the LangChain stuff where I just want you to focus on the libraries, and then I just want to let you know that yeah, there is something called character split chunker, there is something called recursive character shift. I just want you to know all these things, and then whenever I'm talking about RAG stuff, I can go in detail of what this stuff is. Okay? Yeah, but for
Shekhar,
now, go ahead. Go ahead.
Shekhar, so basically now you are giving all models, right? For retriever or like, augmentation.
Mhm.
Okay. So are we going to use same model for all use cases, sir? Or the model is based on like, use case by use case?
Use case by use case. I mean, it varies actually. I mean, uh, model in the sense you mean the LLM or the models that I'm talking about. Either it can be text splitters or the loaders or embeddings or something like that.
No, embedding in the embedding is also you are passing some model name, right? For
Yeah, Olama embeddings, and then I'm using I mean OpenAI embeddings. Yeah, here I'm using OpenAI embedding.
correct.
And then I'm
So
passing text embedding ADA 002. Yeah.
yeah, so even if you're using all these embedding or like retrieving from
hmm
LLMs, so
hmm
you passing some model names, right, as an argument.
Yeah, we need to pass that model name as an argument. Yes.
Right. So do we have like multiple models based on use case? Okay, this model can be used only for this use
Got
case.
it. Got it. Yeah. I mean, we don't have anything predefined as such. I mean, it has to be our intuition, and it has to be constraints. I mean, as I said, for a few use cases, we need to people need latency as their thing. I mean, so they don't want outputs to be delayed. So they want answer in seconds actually. So in that cases, you need to use some models. So yeah, as these embedding models, we are doing this in backend stuff, right? I mean, we will be only creating this embeddings once, right? I mean we will run this pipeline once, and then let's say if we get any new documents or something like that, we will run once in a while, not regularly, right? Yeah, I mean, for embedding stuff, there are few parameters that you need to consider. One would be price. Second thing would be uh, the quality of embeddings that we are getting from the LLMs. So if you are using OpenAI's embeddings are too good actually, because one, because of size. I'll let you know how embeddings are created in the future classes, but because of the size of the data, and then because of the model performance, OpenAI embeddings are the by far the quality embeddings that we have in market. But let's say if you are using Llama model, you can't send OpenAI embeddings to Llama model. You have to use OLlama embeddings. Yeah, there are some correlations. I'll let you know when we go in deep. But yeah, I mean, there is no fixed pattern for this actually, what to use for what use case. But as I said, as this also evolving, as is also getting new updates every day, you have to keep trying actually.
Okay, got it.
Sorry, Raja, you done? Okay.
Sorry, let me give you one example, Shekhar. Okay. Suppose, for example, right now you are taking all the PDFs or text files, right?
Yeah.
Okay. Now, and then once you do the once you store into vector database, now you are applying some LLM to retrieve this data. I mean, based on query, you are getting the answers. Right. So my question is, suppose for example, I have a bunch of logs, application
Okay,
logs.
logs. Okay.
So where I want to see the any anomaly patterns with that logs. Okay, so I can read my logs are pretty much like it's maybe in the flat file or it might be in the some kind of time series database, right? So I read this flat file and do the same whatever we are doing, like read the file, do fragmentation, whatever you call, and then so how I can go and identify that anomaly patterns. So when I call the LLM, you got what I mean?
I mean, it is a bit. I mean, we can use LLMs for this, but in addition to these LLMs are good at just retrieving this stuff, and then I might do fine tuning. I might find the patterns, but I mean, we can use plain data science models to find what exactly the pattern by using the logs. I can do that, but I'm not sure. I mean, what do you want from that use case? I mean, what should be your end goal? Your end goal should be to propose a solution based on the anomaly, or what can be what?
So based on some kind of failures, assume I keep logging my application logs. Okay. At certain point of time, there is some application is down because of that. We are keep logging some errors here and there. So when we see the more errors in the span of 5 minutes or 2 minutes, okay, then it's kind of like abnormal pattern, right? So anomaly, it's anomaly. So there is something is going on. So we have to identify such kind of things.
Okay. Got it.
What I mean, right? So will this LLM will work such kind of use cases, because I'm keep hearing a lot.
Okay.
Everyone is like calling out, yeah, we can use all these kind of use cases with the Gen AI.
Yeah, got it. Yeah, we can connect offline this weekend or this Saturday or any other day actually, and then we can discuss more, Raja. Okay, I
Yeah.
got your point. We can discuss that. I mean, you can ping me. I'll give your number. I'll give my number at the end of the session. You can ping me. Okay, we can talk about that, and then we can see how it goes.
Okay, super. Yeah.
Yeah.
Please pick
For
me.
for an hour or 1.5 hour, we can sit, and then I'll get more understanding of your use case, and then we can see how we can include our LLM stuff there. Okay.
Yeah. Excellent. Thanks,
Yeah.
Shekhar.
Yeah.
I'm
Just
basically intention is I'm trying to understand the use cases, real-time
Yeah,
use
got
cases.
it. Got it. Yeah, got it. Got it. If your use case is okay, we can integrate. We can showcase that to our users also. We can take that example, but not data and all this stuff. We can show that workflow if everything is good. We can use
Yep.
that as a workflow to our class.
Right. Exactly.
Yeah.
Thank you.
Any other questions before we go next, or
Yeah,
can I continue?
this embedding, what it is doing exactly? This OpenAI embeddings is equal to OpenAI embeddings
Mm-hmm.
model is equal to
Mm-hmm.
text embedding ADA ADA 002
002.
or
Yeah.
what?
Yeah.
So
So
it's
this
a
is
name or okay?
yeah,
What is
the
that
model
actually?
name actually. This is a model name that is embedding model name.
Oh, that's already created one by OpenAI.
Yeah, this is what the model that is created by OpenAI. We are just using that. We are just passing our text to that model, and then this model is generating the vectors for us.
Text we are passing to this
Here we are
model, but
passing this
where?
docs. Docs.
Oh,
Docs
docs. Okay,
is yeah. Docs
okay,
is the thing
okay,
that
okay.
we are storing, and then we are
Automation. Okay,
passing
got it.
that docs with embeddings, and then we are creating
Embeddings
the
and then storing in the
vector
chroma DB.
database. Yeah, with
Chroma
the chroma
DB
database.
OpenAI.
Yeah.
Okay.
So yeah, let me go. Let me talk about splitting now. Okay, so I think we talk about two splitting techniques. One splitting technique is the character splitting technique. The second one is the recursive text splitter. These two are the techniques that we have discussed, right? So yeah, this is very pretty much the same, but so here in above cases, if you can notice that I'm taking all the files, and then I'm storing entire thing into vector database. Okay. Now what I'm doing here is that I'm just taking one file, which is Romeo underscore Juliet dot txt. This is a file that I'm taking. Now what I'm doing is I'm just loading this stuff. I'm creating vector embeddings. But my main focus is on not all those things. My focus is on splitting stuff. Okay. Now I want to talk about splitting more. In the next topics, I'll talk about the embedding stuff. Okay. So we talk about loaders. In loaders, we have discussed about text loader, PyPDF loader, web-based loaders, and then Wikipedia loaders. And in text splittings, we talk about character splitter, recursive splitter, and then we have something called sentence-based splitter, where if you want to split the text based on sentences, ensuring that we don't want to we want to we should not uh, cut based on the character limit or word limit. If the ideal thing is that if we have a good number of sentences with the long text in that sentence, so if you split based on the sentence, that would be good, right? So all the semantics will be maintained if you split based on the sentences. So for this, what we are doing is that we are in LangChain, we have something called sentence transformer token text splitter. This is the token splitter. But at another token splitter we have, we will be using that, and then we will be splitting. We will be sending our documents, and then all the documents will be splitted with respect to the sentence-based splitting. Actually, you might be getting doubt here. What splitting technique do I need to use? Yes or no? I mean, do I need to use character? I said character text splitter is the worst thing. We won't be using that much until I mean, we will be using that, but we have to use that when we have consistent chunk sizes. If you don't want to consider the semantics, the stuff, then you might use that. But yeah, you might be having a question of what splitting strategy to use. Yeah, as I said, it we don't have fixed answer for this. Uh, but yeah, I mean, people might most of the scenarios we might be using recursive. Initially, people are using recursive. In my last project, we are using custom splitting strategy. yeah, I mean, there isn't a table-like format where for this case you need to use this, for this case you need to use this. If you have understanding of all this stuff, and if you know what exactly what is the drawback of that thing, what is it's good at, what is it bad at, based on your data, you can choose you can choose whatever you want. Okay, so yeah, and there is something called token based splitting, where if you want to split the chunks based on the token count or words or subwords, you can use token based splittings. Actually, token based splitters uses tokens as the limit. Instead of characters, it takes tokens. And then, as I said, if you use recursive character splitting, there are some natural boundaries where if it encounters comma, or if it encounters dot or new line character, it will take that and then it will split according to that, actually. And then we
Like
have
this
some.
token based splitting is like words only,
Yeah, it
definitely, like,
splits.
or
It splits based on words. I mean, if it is Shank 512, it splits with 512 words instead of 512 characters. Okay, it
okay.
splits based on words, not based on characters, actually. Token based splitting. And then we have something called custom splitting, where here I didn't write much functionality here. I'm just splitting based on the paragraph. Here it is, you can say it as paragraph splitting, right? So yeah, custom based splitting, you can write something, some functionality. So let me explain our custom built in my last project, whatever the custom splitting technique that we have used in our last project. I'll explain that for you now. I don't. Okay, so what is our custom logic is, let's say in our chunking thing, what we did is that, uh, let's say what we are doing is for each chunk, we are assigning the chunk numbers, actually. So what do I meant by that is, let's say if this is chunk 1, if it's chunk 2, we will be grouping. I mean, before this, what we are doing is, let's say if my document is having sections, subsections, and then the subsections, or if it is having tables, what we are doing is, for this under this section, I mean, most of the documents will have all this stuff, right? Section, we will be having subsection, and then we will be having subsection. So most of the times, of what we did in our thing is that we have assigned the chunk numbers to the section sub. Let's say if this subsection has divided into 3 chunks, okay? So let's assume it as subsection 1 chunk 1, subsection 2 chunk 2, and subsection 3 chunk 3. Why we have assigned this is that, let's say if LLM is retrieving this this as my input, so what we are doing is that we will be fetching these two also. We don't want false risk to be more. So what we are doing, what my our chunking strategy is doing is that, by assigning chunk numbers to each section, subsections, if my information is more in this, there might be some information here and there, here and here. So what we are doing is that, let's say if LLM pulls this chunk, we'll also, in addition to this chunk, we'll also pull this and this chunk, so that LLM might not miss the small, minute details also. LLM might not miss this information. So yeah, in chunking, there is a there is around 200 lines of code where how do we split actually? Splitting and assigning numbers to sections, subsections. We have analyzed the format of the documents, and then we come up with some custom logic actually instead of the logic that I'm talking about here, the recursive splitter, character splitter. What we did there is that we have had a different option. I'll walk you through that whenever I'm talking about an enterprise application. I said we had one enterprise application, right? So I'll talk about the custom logic there. Okay. Yeah, we can also write the custom logics like that in our custom text splitter classes. You can write something and then you can call that. Okay. So here what I'm doing is that this is just an fetching thing where what I'm doing is what I'm doing here is that I'm based on some similarity score threshold. I want to fetch the chunks, and then I want to display the document, and I want to display the source as well. Here what I'm doing up is that I'm creating vector database for all the strategies that I talk about: the character-based splitting, sentence-based splitting, token-based splitting, and then recursive-based splitting. For all this, I'm creating vector databases, and then whatever the vector database is, I'll pass the vector database, and then I'll pass the query to just check how the results varies for each call. So if you use what happens if you use the character space splitting, what happens if you use you just need to know that, right? For that, see. So here, if I use character based chunking for my question here is, how did Juliet die? So this is my question. For this question, this is the relevant document that I got. The thing is that here we are just retrieving the information. It is not 100% sure that we will be having answer in this relevant document. Okay, so we might fetch. See here, based on these parameters. See here, the parameter is threshold is just 10%. You can have threshold to be 40 or 50%. So if the relevant information is present in that chunk, which is with 50% matching, that will fetch that. You'll fetch that document. You'll fetch that chunk. It need not to be the exact answer for the question, but there might be high chances that the chunk might be having the answer. Okay, and then that is the reason why instead of just retrieving the stuff, we are just collecting the chunks, and then we are passing LLM, and now we are asking LLM, these are the relevant chunks that I got from my vector database. Now you need to think logically, and then you need to apply your skills, and I want you to check all these chunks, and then this is the question. Answer this question according to my chunks. That is what I'm asking LLM. So yeah, so what I want you to do is that you just go through all the chunks, all the retrieve chunks, and check whether which is performing well on that question. Most of the cases, in two or three, in all the cases, we might get good chunks because this is small use case. But let's say if you have ambiguous questions, text splitter might not work well. So you need to know all this stuff. Okay, so these are the text splitters I want to talk about. So as I said, characters-based text splitter, recursive text splitter, sentence-based text splitter, token-based text splitter, and then custom-based splitting. These are the text splitters that we have. In addition to that, we have something called context-based text splitting. This is also there, but this is not widely used because what we are doing with the context-based text splitting is we are passing our document to LLM, and then we are asking LLM to split based on the context. not based on the para or not based on the sentence. We want LLM to split based on the context. But the problem here is that if you use LLM, latency will be high, and then cost is also involved, right? So that is not the recommended one, but this is also an option actually. Context-based text splitting is also an option. These are the available text splitters that we have. I think we are about to, I think we are 9:30. So what we can do right now is I plan to do embeddings as well. Embeddings, I thought to cover two embeddings, no problem. And then I thought of saying these parameters, similarity, what is similarity, scotch, all this stuff. Okay, we'll see tomorrow, no problem. I'll complete this RAG based stuff, entire RAG based stuff tomorrow. So actually, we are here. We are talking about text splitters, loaders, embeddings, retriever. So we only completed text splitting and loaders. We'll talk about embeddings, retriever, one-off question, and then I need to start talk about agent stuff. Okay, I'll talk about agent stuff, and then we'll see how it goes. This is a complementary session. I haven't included in our course part, but I thought of saying this deep learning. Okay, yeah. This I'll stop here. If you have any questions, you can ask. But
Shekhar,
yeah,
I have a
I'll. Okay, go
to
ahead.
Yeah, you remember like you had it in embedding or this one splitter, you had model like OpenAI text model 2 or something. So how do you know which model to pick and all? I'm assuming there might be multiple models and multiple things. So where to refer and what to use? How do you decide that?
Yeah, I think I have answered this question again. The thing is that, as I said, we had. I mean, if you are talking about embeddings, the embedding models, as I said, OpenAI embeddings are good, but if your client is focused on cost constraints, we should not use OpenAI models. In addition to that, we have a repository which is called Hugging Face, where in this Hugging Face, you have so many open source models with some which performs good on so many benchmarks. So you can take that and then you can implement the embeddings actually. Or else, as I said, if you are using Ollama embeddings, I mean, if you are using Llama 3 as your model, as your large language model, definitely you have to use Ollama embeddings. If you are using OpenAI, so the good approach that you need to use is that you need to use OpenAI embeddings actually. So whatever the large language model that you are using for the generation, so people generally do consider to use the same embedding stuff. They don't pass different embeddings actually. They don't use cross embeddings. Let's say if you are using OpenAI LLM, Llama, OpenAI's GPT as LLM, people generally use the OpenAI's embedding models itself. Llama, they'll use Ollama embeddings. And
Yeah, I
then
got this.
to
Yeah.
choose between OpenAI and then Llama, it depends actually. So if you are having cost constraints on LLMs, or you have to know what embeddings performs when, based on the vector database, also based on the size of the vector database, you need to choose the embedding models. So there are so many factors. We'll talk about that factors whenever we are talking more about RAG systems. Okay,
Yeah.
RAG and advanced RAG architecture. I'll let you know what to choose. But I mean, as I said, if it is 50%, we can give the information of what to be used when. But it totally depends on use case. Also, it totally depends on many other factors. I can give a peripheral idea, but I can't completely say you have to use this for this.
No. But where to find which all model exist and all I remember you showed in the very first few days, like some document where reference, like how do I know how many models are available and all those things. where to pick, and how to do research on those?
I can share that. If you want, I can share what are LLMs are there, what are embedding models are there. I'll share that. That's not a problem. I'll share that in classroom. See, if I miss anything, I'll comment. I'll post here. One day we were talking about LLMs, I think, and then someone has asked me about catch, whether the LLMs use catching or not. I mean, let's say if I ask you any question related to hot topics, whether this is stored or not. So I think I have shared that, I mean, this information about prompt catching. So you can, I mean, if I miss something in class, if I say I'll get back to that, I'll definitely add that in. See, and then one day Nanda has asked me about rate limits on OpenAI. So yeah, if I ask something, you please follow this classroom. I'll definitely post there. I'll definitely post there on this topic. About what are models, various models, LLM models that are available, what are various embedding techniques that are available. I'll post that chat.
Thank you. Yeah.